Hello and welcome to IG Physics. We're looking at two important parts, Unit 2.8 and 2.9, I think, about friction and weight and gravity. Okay, so we're going to look at weight first. So firstly, the first question that we want to ask is, what is gravity? Okay, gravity is an attractive force of one object on another object. Okay, it exists everywhere that matter exists. So every object that has mass has a gravitational force between every other object in the universe. The strength of these forces between the two objects is dependent on two factors. Firstly, the masses of the object. The bigger the mass, the greater the gravitational force. Secondly, the distance between the objects. The closer the objects together, the greater the gravitational force. But hey, wait, so does that mean that I am attracted to the guy on the other side of the planet at the moment, or the girl, or actually any object in the universe? Yes. The reason why you're not floating or flying towards that person is because you are much lighter, and that person is much lighter compared to the Earth. So the gravitational force of the Earth is much bigger than any other force that exists, any other gravitational force. Okay, so a few examples. Most objects in the universe are too small to have any noticeable gravitational effect on any other object. Okay, but the biggest two gravitational forces that are noticeable are the Sun. Okay, it's very heavy. It's the most massive object in our solar system and exerts a huge gravitational force. This is why all the planets stay in orbit around the Sun. Secondly, our Earth is so big that the gravitational force keeps us from falling off the Earth. Another one is the Moon. How does the Moon affect gravity on Earth? If you think about the solar system and the tides, okay, or the moon cycle and the tides, how the moon actually affects the levels of the ocean because of gravity. And then last but not least, when an astronaut's in space, they float, not because there's no air, but because they are far enough away from the center of the Earth or any planet that gravity isn't strong enough to hold them down. So where you float is where you are without gravity. Okay, so what's the difference between mass and weight? The Earth's gravitational field is 10 Newton per kilogram. In other words, a 1 kilogram mass is pulled downwards by a force of 10 newtons. Okay, now according to Newton's second law, the resultant force is mass times gravity, and in this case the resultant force is the weight. So the weight, which is a force, is mass times gravity, and that's how we convert our mass into gravity. So we simply times whatever is the mass in kilograms by 10. Okay, and check the units. Mass must always be in kilograms. Okay, now you need to learn this equation here. There's a triangle there on the right that you can look at as well. What is the weight on Earth of a book of mass 2 kilograms? You times that with 10, you get 20 newtons. What is the weight on Earth of an apple of mass 100 grams? Danger! Why is there danger? Because you can't use grams. You first have to convert. That is 0.1 kilograms times 10 gives us 1 Newton. Okay, so Charles weighs 70 Newton on Earth. This is not our Charles, by the way. And what is his mass? His mass is, if we take our gravitational force, if you look at the triangle, we have the weight, we have the G, we want the M. So W divided by G, 700 divided by 10 is 70 kilograms. On the moon, the gravitational field is 1.6 Newton per kilogram. What will our friend, not our Charles, but Charles, do if he weighs, what will he weigh on the moon? So we take his mass of 70, times it by 1.6, and we get 112 Newton. That is the quickest weight loss you'll ever do. Just migrate to the moon and you'll weigh 6 times less. Okay, so what's the difference between mass and weight? Here's just a quick image. Difference is mass is a scalar and weight is a vector. Firstly, it has magnitude, mass has magnitude only, and weight has a direction which is downwards. Okay, so mass is measured by a balance and weight is measured by a scale. Okay, so yes, you are measuring your weight with a bathroom scale, and that's not actually your mass, because if you move up and down while you're standing on the scale, your weight changes. Your mass is not actually changing. The force that you're exerting on the floor changes. Okay, so we measure the one in mass and the other one in kilogram, and I think you've seen enough big pink pictures flashing to get the idea. Okay, the next part is friction, guys. So friction is a force that opposes motion between two touching surfaces. Okay, at a microscopic level, even the smoothest surfaces have rough edges. Okay, therefore these rough edges push against each other, causing friction. Okay, so there are two types of friction. The first type is static friction, and this is the friction caused by applied force, okay, at an object, okay, at rest. So if we look at the object below, there is a force. Now I always say that frictional force never starts the fight, okay? Friction is never the force that starts. Friction always responds. Now if I push with 1 Newton, the frictional force will respond with 1 Newton. If I push with 5, it will respond with 5, up to the point where I push more than what the frictional force can be. So the frictional force depends on the roughness of the surface and the mass or the weight of the object. Okay, so once I apply enough force, I have enough force to overpower the frictional force, and at that stage we have what we call kinetic friction, and that is when the object is in motion. Now a small hint is that your kinetic friction is always less than static friction. So what's the application? It always takes more force to start moving a heavy object, but as soon as it moves, you don't have to push as hard. But if you don't push more than the minimum kinetic friction, the object will slow down and stop, and then you will first have to push again at the static friction. Okay, so there are three basic places, examples of friction. The first example of friction is when objects slide across each other. Okay, this is like trying to push a file cabinet across the floor, usually a very high frictional force. The second place where friction occurs is when objects are rolling, okay, roll over on each other, like pushing my wheeled chair across the floor. The wheels decrease the frictional force. So by adding wheels to an object, we have less surface in contact and we have less frictional force, and that's why it's easier to move something with wheels than something without wheels. And last but not least, fluid friction, guys. Now fluids, contrary to popular belief, does not mean liquid. Fluid means liquid or gas. So fluid friction can be either air resistance, or it can be any liquid or oil or anything that you move through. So it occurs between an object and a fluid, which is either a gas or a liquid. Okay, like an ice skater, okay, so the ice skater moves through the air on ice, okay. um, the ice skater, we're not talking much about the skates in the ice, but we're talking about the ice skater. When these figure skaters and these speed skaters want to go really fast, they need to bend their bodies and make it smaller so that they have less air resistance. A plane flying through the air molecules have fluid friction. The air molecules rub against the plane, making it more difficult to move. And then obviously, guys, if you swim through water, then the water opposes your motion, and therefore it's also fluid friction. So three places where we would find it. There might be more, but in any more real life situations, there's no motion or movement that does not involve friction. I hope you understand this, and if you've got any questions, please let me know. Have a nice day.